So the last page in your notes that we did not get to fill in is reviewing graphing linear inequalities. And then the new concept in this is graphing absolute value inequalities. You already should have learned graphing linear inequalities when you were in Algebra 1. So this front side of this page should be more of a review for you than anything else. So let's go through the steps and then we'll do an example down here at the bottom. So when we graph a linear inequality, if we were graphing a linear equation, we would simply graph the line and all the solutions that solve that equation would be on the line. But a linear inequality has a greater than or less than symbol in it, kind of similar to this one here, okay? And when you have those on your in your equation, the solution is not just the solutions on the line. They could be, they might not be. They could be that, but they also could be an entire region that is shaded below or shaded above the line. That's what the greater than, less than symbols refer to. So we're going to start out by treating the equation or the inequality exactly like a linear equation. So we're going to solve for y. And these steps also apply to the absolute value inequalities. The point is the y has to be alone. Then we're going to graph the line. So if it's a linear equation that we're graphing, then we're going to graph it using slope-intercept form. If it's an absolute value inequality, then we're going to use one of the methods that we learned in class today on how to graph those. Now, let me go ahead and do that portion first, but let me mention one thing about the graph. When I graph, the line is going to either be a solid line or a dashed line. Let me explain to you what that means. If a graph has either less than or greater than, or less than or equal to, or greater than or equal to, if it has one of those symbols, that means that the solutions to the inequality also include the solutions that are actually on the line. It's kind of like an open circle and a closed circle, okay? If the equation or the values include the solutions on the line, then it will have one of these symbols. And if that happens, we're going to draw a solid line. Okay. If it does not include the solutions on the line, then it's going to just either be a greater than symbol or a less than symbol. So unless you see that or equals to, it's going to be a dotted line. Okay. So if you look at my example here, I have a less than symbol, which means it does not include the solutions on the line. It's only going to include the solutions below the line. Okay. And we'll talk about that shading part in a minute. So let's go ahead and solve this for y. This is a linear equation or a linear inequality. I get negative 3y is less than, and I'm going to put the x term first, negative 2x plus 12. And then to solve this, I have to divide by a negative 3. Now remember, this is an inequality. If you divide by a negative number on an inequality, the sign has to reverse. So it's going to go this way. Negative 2 divided by negative 3 is still going to be a fraction, but the negatives cancel. So it's going to be positive 2/3 x. And then 12 divided by negative 3 is negative 4. So here is, you can write all this on your, I fit it all inside the box on mine. But on the Scribbler here, I can't do that. So here is the inequality that I'm going to graph. So I'm going to graph the line, keeping in mind that because it's a greater than symbol now, and it doesn't have the or equal to, once I plot my points, I'm going to draw in a dotted line, not a solid line, okay? Because it does not include the solutions on the line. It's only going to include the solutions greater than that, okay? So negative 4 is my y-intercept, so I'm going to put a point on negative 4, 1, 2, 3, 4. And my slope is 2/3, so that's going to be up 2 and to the right 3 because it's a positive slope. So it's going to look something like this. And I can continue it in the opposite direction as well. Now, I'm going to make a line. My line is not going to be dotted yet. I'm going to go back through with my eraser here, and I'll go ahead and erase and make it dotted. You can just actually sketch, when you get ready to do yours, you can just kind of make yours dotted as you go. a second. Let me make my eraser a little bit thinner. So hopefully I can make this a little bit better. There we go. When you make this on yours, you will be able to do yours from the get-go like this. So you're going to see a dotted line there, okay? Not a solid line because it does not include the solutions that are on the line. So after when you decide on the line, that's what you graph when you graph the line. The last step is to shade the region that all the solutions that fall in that region would satisfy this inequality, okay? And by the way, the sign reverses. We just did that, okay? So let's talk about the shading, okay? If the symbol is a greater than or a greater than or less than, okay, you are going to shade above the line. If it is a less than or less than or equal to, we're going to shade below the line, okay? So in this example, it's a greater than. So when I get ready to shade, I am going to be shading above the line. Here's the line. Above it would be all of this region over here. So there would be my solution to this inequality. The solution to this inequality is an entire region of points. Any point in this yellow region, if you were to plug in the values of those points for x and y, the left side would be greater than the right side, okay? And I'm not going to do one of those right now, but just know that that would be true, okay? So for example, I could do something like 3, 2. I'll do 1 point. If I have the point 3, 2, and it falls in that range or that region, that means that when I plug these in, I'm going to get a solution that is true. So if I plug in a 3 for the x and a 2 for the y, okay? If I plug in a 3 for the x, the 3's are going to cancel. So I'm left with 2 is greater than 2 minus 4. Well, 2 minus 4 is negative 2. That is a true statement. 2 is greater than negative 2. So any point in this region satisfies the inequality. Now, if you weren't sure if you shaded in the correct place, this is a way you could self-check. You pick a point, plug it in, and see if it gives you a true statement. If it does, then you know that you shaded the correct region. Okay. So in the next video, we'll see an example of this using an absolute value function or an absolute value inequality.